Hello everyone, welcome back. Today we are going to discuss about concurrent hash map. So the prerequisite for this is that you know already about hash map and about collections. So we are directly going into concurrent hash map and how it works internally. So we'll go through the question answer model, which will be easier as to explain very detailed. Start with how concurrent hash map stored internally. Internally, concurrent hash map stores data in an array called a table. This is the table and it is stored. Each node is stored as a keyword value. So this is called a bucket. Each bucket, this bucket contains a single node. Inside a single node, it will be linked to through a linked list. When there is a collision occurs, and when the linked list length is going in a very long manner, then it will move the complete storage will be moved to red black tree, not as a linked list. How does concurrent hash map calculate where to store a key? If you already know about hash map, we already know the hash map always stores key based on its the hash code method and equals that we know very well. So now here how concurrent hash map what it does, that is a main thing. It is has a little minor change as it is a thread safe. First, Java calls the hash code method. It will calculate the index, the table size index this. So the key here, if you see, this is the formula table length dot minus 1 and hash. The table size initially it takes as 16 and then hash value based on the hash code is 25 and the index is calculated based on the table length minus 1 ampersand 25 is equal to 9. So the key will be stored in the bucket 9. What happens internally when put is called? When a put method is called, the first one it will calculate the hash which we know already, and then as I showed above, we need to find the bucket index. After finding the bucket index, we will check whether the bucket is empty or not. If the bucket is empty, so we don't need any lock as it is a new bucket and there is no going to have any thread safe concern. So it will do compare and swap to insert the node. Compare CAS means here compare and swap, no lock required. But if the bucket is not empty and if the bucket has the data, then that bucket needs to be locked. So the log only that bucket and then insert that node accordingly. Once the write happens, so we release the lock. So the entire map is never locked. So concurrent write and read is possible. Why doesn't put always use a lock? Why doesn't it always, as we saw already in the above question, because Java first tries the compare and swap, which will compare the previous value and then with the new and then it swaps. So if the bucket is empty, when there is the bucket, the where we are going to write the bucket is empty, there is no purpose of having a lock itself. So in this case, no synchronization is needed. Locking happens only when another node already exists. What happens when two threads write to the different buckets? As it is writing in a different bucket, and if the bucket doesn't has any data, obviously what will happen? Since both buckets are different approach, so no blocking occurs here. That is the reason the concurrent hash map is used widely in most of the application. What happens when two threads write to the same bucket? Yeah, here obviously we need the locking. Suppose both keys has to bucket 5. Thread 1 enters first, it locks the bucket 5. And thread 2 waits. After thread 1 finishes, thread 2 acquires the bucket lock and continues. Only bucket 5 is blocked, other bucket continues working. As I said, it is same. How does get work internally? So whether here the main intention of this question is whether the lock is required for the get or not. The biggest advantage of concurrent hash map is get usually doesn't acquire any lock. That is the biggest advantage. So it will calculate the hash, find the bucket, transfer the link tree, it will return the value. Since reading doesn't modify data, locking is not required. Java relies on volatile fields to guarantee visibility. If get doesn't lock, how does it read the latest value? The node fields are declared volatile. One thread writes value 100, another thread immediately sees 100. Because volatile forces memory visibility, without volatile, thread B might continue reading an old cache value. So the node is declared as volatile. So we are able to read the latest value always. So what is CAS and why it is used? As I say, CAS is nothing but compare and swap. Mostly it will be used in atomicity. Imagine two threads writing to insert into an empty bucket. Instead of locking, Java's asks CPU replace null with this node only if it is null. If another thread already inserted a node, CAS fails and retries or fallbacks to locking. This avoids unnecessary synchronization and improve performance. This always improves the performance because of compare and swap, we are not having any lock mechanism here. What happens if many keys go into the same bucket? Initially, collisions are stored as a linked list. So when the length goes on, it will be the collision started to occur. So then if the list becomes too long, more than 8 nodes, the table is sufficiently large, the Java converts into a red black tree. It is an internal implementation. It is just for our knowledge. So searching becomes ON to O log of N. So the improvement is good. But insertion and other things might take things, we need to check on them. How does concurrent hash map resize? When the table becomes full enough, Java allocate a larger table. Unlike hash map, one thread doesn't move everything. Multiple threads cooperate, making resizing faster. So if the table length becomes more, if single thread process this reallocation, then only it will take a lot of time. So what it happens is the thread A moves bucket one, thread B moves the second bucket. Internally, the multiple thread is working to make the process very faster to make this bucket handling. So what is forwarding node? There is a concept called forwarding node which will be used in this reallocation. During resizing, a bucket has already been replaced with the forwarding node. So when the old bucket is there, that bucket will be point to a forwarding node text. And the forwarding node will internally points to the new table. So mainly this indicates when there is a multi-thread, one thread, if thread A moves the bucket one to another location, thread B when it try to reach in the same old location, so the forwarding node will redirect it to the new table. Why doesn't concurrent hash map allow null keys or values? In hash map we allow null keys once, but concurrent hash map doesn't allow. Why? Because in a concurrent environment, ambiguity is unsafe. By allowing null keys, the values null always means the key is absent. So when it is multi-threaded environment, it is unsafe to use null. So that is the main reason the null is not allowed in the concurrent hash map. Why is concurrent hash map faster than a hash table? Hash table uses a single lock for the entire map. So when we want to write or read, the entire map will be completely blocked. So that makes the delay. Concurrent maps locks only the affected bucket. This allows many threads to operate concurrently. So if you want to explain the complete flow of put, this is a short answer. And when put is called, this is a concept which we already explained, it is a overview. When put is called, concurrent hash map first computes the hash key and determines the bucket index. If the bucket is empty, it tries to insert a node using CAS operation. CAS operation, whether it is a null or not, avoiding any lock. If the bucket already contains node, it synchronizes only on that bucket, traverse the linked list or tree, update the existing value if the key is present, or appends a new node if it's not. If the number of nodes in a bucket exists the threshold, we saw the sample threshold is 8, exists the threshold, the linked list is converted into a let back tree. If the overall load factor crosses the resize threshold, multiple threads cooperate to transfer the bucket into a large table using forward node to coordinate the migration. This design minimize the contention while maintaining thread safety. The main concept is that we are not locking an entire bucket, we are locking the bucket which we are trying to write. Even if it is a new bucket, then we are not locking anything for the write. That's the first important point. The second important point, we are using CAS to check whether it is empty or not, compare and swap. When the linked list size grows, we are changing to a red black tree for the greater optimization. When that is happen, it uses the mechanism of multiple threads you have used to transfer the buckets in a very faster manner and use forwarding nodes to coordinate the new bucket location. So now we will see a real-time world scenarios where, sorry, typo, real-time world scenarios where the concurrent hash map is used in Java mostly. So API rate limiting, most common. If you're, suppose your application exposes REST APIs and you want to limit each client to 100 requests per minute, you can do it with the concurrent hash map. So this is at rate server limit service. You can have your, the concurrent hash map, and you can allow requests to the specific client IP or something like that and make the counter using the atomic integer. So you can ask the rate limit can be done through YAML configuration also. This is one sample example where if you want to monitor the limit counter based on the client. This is one time real time scenario, we can use it. So in memory cache, in our project, we use this concurrent hash map when we have a single node methodology. Instead of using distributed systems, we will use this in memory cache also. So we will use the concurrent hash map here, there. So we can have our product ID and the product detail. So we can use it. So it is best to use compute if absent instead of using contains key. So concurrent hash map, if 100 users request product 101 simultaneously without doing 100 DB calls, we can use one loss from the DB. So this is have a huge performance improvement. It is really used in our application scenario also. User session tracking. Yes, if you have your users which you want to track in a, in a session tracking system, then you can use this also. It mostly used whenever session ID based, session object based tracking happens. And real-time chat application. You have a multiple chat instance. If you want to store the user ID and the chat discussion as a WebSocket session, there also you can use the concurrent hash map. OTP verification service to store the OTP, generated OTP store. For the example, you can use thousands of user requesting OTPs simultaneously. That is a real world example. Tracking active orders. Whenever I have my order, I'm in a single thing, I can add 10 items in mostly in our, like in big basket or something, we will do that. So this is my order ID I'm preparing, and all the order details can be done as a concurrent hash map. And in related to our Kafka, when we are receiving our events, if we thought we need to store the event ID and related to that stuff, we can also use this concurrent hash map to avoid duplicate events. and gaming related scenario. This thousands of players updating the score simultaneously. There were the player details and the related to the player score. We can store it using atomic integer. Stock inventory, request metrics. So yeah, that is all login orders payment. So you know why not to use HashMap. HashMap is not thread safe, so we will not use that. It will lead to the concurrent modification expertise. So these are some best practices of using the concurrent hash map. Use compute if absent instead of contains key followed by put. Always, whatever, when we do concurrent hash map retrieval, we always check whether the keys exist. If it is exist or not, then only we'll do put operation or something like that. That is often happening. So instead of that, the compute if absent is a very good method. Use atomic integer or atomic long for mutable counters stored as values. This is always preferable. It's general. Use put if absent. Are they same thing? Instead of checking contains key and then put if absent is another one time initialization. Prefer compute merge and replace for atomic updates. Don't use concurrent hash map as a replacement of Redis. We can't use complete Redis cache because we can Redis is mainly designed for that and it is used in the distributed application. This concurrent hash map is just that we are using inside a single node or for a for temporary purpose, which is very mandatory. There we can use the concurrent hash map. It is not replacement for the distributed cache. I know, hope everyone knows that. It is just a thing. Yeah. So that's about concurrent hash map. So we can next see about any other great interesting collection topic in the next section. Thank you. Bye.